Hi friends, this is Dr. Sumati, Professor in the Department of Electrical Engineering, Indian Institute of Technology, Roorkee. I am associated with Advanced Instrumentation and Artificial Intelligence Research Group, where we work on signal processing aspects as well. This course, Two-Dimensional Signal Processing, Principles and Practices, is designed for both undergraduate and postgraduate students. This course is structured in such a way that it introduces two-dimensional signals and its processing facets along with real-time implementation. At the outset, this course reviews the fundamentals of one-dimensional signals and one-dimensional systems, one-dimensional signal processing aspects including signal classification, signal operations, sampling theory, one-dimensional Fourier analysis, and one-dimensional Z-transform. Each weekly module is designed to introduce two-dimensional signals and its processing by reviewing the one-dimensional aspects of it. Also, the two-dimensional extensions are detailed and emphasized in each module. Second module covers the fundamentals of two-dimensional signals and systems, characterization of linear time invariant or linear shift invariant systems, convolution, impulse response, assessing stability of systems. Next comes transform domain details, Fourier analysis of two-dimensional signals such as 2D discrete Fourier series, 2D discrete space Fourier transform, 2D discrete Fourier transform, and 2D fast Fourier transform. Obtaining two-dimensional discrete cosine transform, two-dimensional discrete sine transform, Hadamard transform, and KL transform will also be taught in this course. Further, 2D Z transform, linear constant coefficient difference equations, that is LCCDE for 2D systems, have also been included in this course. Two modules are dedicated for two-dimensional digital filter designs, especially FIR and IIR filters. These modules elaborate finite impulse response and infinite impulse response filter designs through various design methods. To understand these filter design concepts and its frequency response, simulation of these designs will also be done through MATLAB and Simulink environment, and the implementation aspects of these designs will be demonstrated through LabVIEW based compact reconfigurable input-output systems, that is LabVIEW cRIO. Finally, image processing fundamentals, image enhancement techniques, image segmentation methods, and image coding will also be looked at as an application of two-dimensional signal processing concepts and algorithms that are learned through this course. These image processing techniques will be taken up for real-time implementation as well. It is important to emphasize that this course introduces MATLAB Simulink environment, LabVIEW based compact reconfigurable input-output systems, and FPGA implementation of image processing algorithms. This course is designed for the duration of 12 weeks with weekly assignments. Live sessions will be conducted to have meaningful interactions. An examination will be conducted at the end of the course to earn the certificate. I thank National Program on Technology Enhanced Learning and the Ministry of Education for providing an opportunity to reach out to you through this platform. Hope you will really enjoy this course. Thank you.